So hi everyone. On today's this video, I'm going to solve this uh, one question, which is uh, for checking that it's valid anagram or not. So the problem given is like given two string s and t, written true if t is an anagram of s and false otherwise. Okay, so anagram is basically same word, uh, but same word, uh, but like the each letter, the position of the letters are different here. So you can see this anagram and this one, so they both are same, just their letters are, positioning of the letter is very different. Okay, so how we can do this? So you can see that here it is rat and it is car, both are containing a different letter here, alphabet. Okay, so now let's begin with the solution, how we would approach it. And so first of all, we would check that the length of both the so first we would do is check whether the length of both the words are having a both the string are equal or not. If not equal, then it's understood that they both cannot be anagram. Okay, so we would return false. And what the other thing we would can do is, like, if the length of these strings are equal, then we should try to keep the count of each alphabet occurrence. Okay, so how many times each alphabet has occurred. So for that we can do is s counts. Okay, and can declare it as a initialize it as an empty object. Okay, same we can do for uh, t. So what here t and s counts and t count is doing is, like, we are means like counting the number of the word alphabet which is going to appear in this string. Okay, so now what we can do is we are going to go through the loop of at I equals 0. Okay, and we are going to loop it through the string s, and for each alphabet we are going to create a key and the value and keeping the count. So what we can do is, like, we can check if, like, um, in s count whether this key exists or not. If it does not exist, then you can do is, or you can do is, you can increment, means like initialize a variable, sorry, initialize a value as 1, or else you can increment that value. Okay, and here in this block you are initializing 1, and in this block you are just incrementing if there is already this alphabet. Okay, this letter is already there. Then we can do same for for t string. Okay, just replace wherever it is s with the t. Okay, and the s count should be t counts. Okay, same logic. And what we are doing here is we are creating an object of both the strings, which would keep the record of each alphabet, how many times it has occurred. So suppose here it will see for a, it would check first if there exists a key in this object. So if no, then it would initialize it with the 1, and then it would go for the n, and then n it would check for the n, and it would again initialize it. Again it sees the a. Okay, so whenever it sees the a, and if a is already existing here, okay, so it will go to this block and just increment the number of the a, which would be 2 in this case. So that is how we are keeping the track of the numbers, means like the occurrence of the each alphabet. So now after creating these two objects, what we need to do is we need to again do a for loop, and like we can loop over, iterate over the object also. So we could iterate over only one of this object, which would be s count. Okay, this, and then we could do s count, and then we could do is a comparison of each and every key, because both the key would exist in the same both the objects, right? If there is a count mistake, means like if a is appearing in this first string three times, let's say, and in second string it is appearing as a 2 time, or whether it's not appearing, then this condition we want to like exit this whole process, that no, it's not an anagram. Okay, so for that we can give a check of like we can keep the condition like this, where we are what we are doing is we are checking for if like this key is not equals to so it would return a false. And after this loop is successfully iterated over, and whenever it detects like there was no false cases here, then it would come out here. Okay, so in that case we would return true, which would prove that it is a anagram. So like first we begin with checking the length of the s and t string, and both the string, if the length they are not equal, then we would directly return false in this case. And then we initiate two objects like s, we are named s counts and t counts, to keep the track of each alphabet which appears in this string, both the string s and t. And so like how much time it does appears. Okay, so then what we do is we iterate over this s string and check whether this key means like this index key is already present or not. Okay, so in that case like a is present or not, then if not, then we could we are initiating with 1, or otherwise we are just incrementing the previous value, keep on incrementing this. The same is done for the t also, and t counts is made. So now what we are doing is like we are iterating over the s count. So in JavaScript we can iterate with the help of this method object.entries. Okay, so um, over the object. So then we can check t counts key, like if the key a and the key of s count key a would be are equal or not. Means like in this case, if 3a is in the s counts object and 3a is in the t count object, okay, then both are equal. So that case this condition fails. Okay, so suppose if letter does not exist in the t counts object and it is existing in this s count, then this would return false. Then we should break the loop and we should return the false, because already there is a mismatch and there is one letter mismatch here. And if third condition is like if there is no in t counts there is a 2a and in 3 s counts there is 3a, then also this condition would satisfy and we would return false. So in that case we would break this loop and return false, that like this is not an anagram. Otherwise, like if this whole loop has been successful, means there was no return for false condition here, then we would return a true. Okay, so now let's run this code. And as you can see, this is how what the two test cases which has we have passed. So now coming to the time complexity and space complexity. So time complexity, whether you can consider ignore these constants like o1 order of 1. So you can catch this loop which is order of n. This also can run towards the n. Okay, order of n. And then it would be this would be also like order of not n, it would be of order of 26, because like there is only 26 characters. Okay, 26 alphabets in English keyword English word. Okay, so this would be order of 26, which we can consider as order of 1. Okay, so time complexity would be order of n and space complexity would be order of n also. Yes, no, it's not going to be order of n. It's actually going to be order of 26, because there is only 26 letters in the English alphabet. Okay, so then space complexity would be order of 1. Yes, so this is what valid anagram problems look like. Okay, so yes, so hey guys, and this videos is part of my daily challenge. Like I'm pushing one video per day for the coding challenges. Okay, the so to enhance my coding problem solving skills. So yeah, keep on watching.